Our aim here is to find the equation of a line, and there's quite a few things to consider in doing this process. Our endpoint is clearly to find the equation of the line. We know it's parallel to another line which is given to us as 6x plus 2y equals 4, and we also know it passes through the point 2, 7. So we need to break up those facts. Let's keep in mind what parallel means. We know from railway lines, indicated here with the orange lines, that parallel lines never meet, and they also run in the same direction. So if you've got lines that are parallel, that means that they're actually the same gradient because they're going in the same direction the whole time. So what we need to do is work out the gradient of the line 6x plus 2y equals 4. If we know that, then we can work out the gradient m for our new line. Let's start by rearranging the equation so that y is by itself. We'll remove the 6x from the left-hand side and take it to the right-hand side where it becomes negative. Now let's divide both sides by 2 so we can get y by itself. And we'll do some rearranging. We'll take the negative 6x term, now divided by 2 to become negative 3x, and place it at the front of the right-hand side, and 4 divided by 2 is 2, and we'll place that at the end. So the gradient for this line is negative 3, and that means that the gradient of our new line is negative 3 because it's parallel to the old one. So we can substitute that into our original form of y equals mx plus c for our new line. And now let's substitute a point in to help us find c. We'll substitute in the point 2, 7 which has been given to us, remembering that 2 is the x value and 7 is the y value. So we'll place those in the respective parts of the equation. We can see here we've put 2 where the x is and multiply that by negative 3, and 7 in blue where the y value was. And that gives us 7 equal to negative 6 plus c. And what we'll need to do now is remove the negative 6 so we can get c by itself. So we'll add 6 to both sides of the equation, and that means that our y-intercept c will equal 13. So we can place that in our original equation where we've got a gradient of negative 3 already, and we'll get y equals negative 3x plus 13, where x and y represent any point on the line.